All right, welcome back to Show Your Work. I want to talk about a proof today. This is the proof of the Pythagorean Theorem. Now, there's lots of proofs of this out there. This is one of the oldest known facts and therefore oldest proofs in math. But I want to kind of talk about the OG, the original one. So, first, to refresh our memory, what is the Pythagorean Theorem? Well, it talks about triangles, specifically right triangles. What does it mean to be a right triangle? It just means it has a right angle somewhere in there. So we call the two sides next to the right angle legs, call them A and B, and we call the longer side the hypotenuse, C. And the Pythagorean theorem says for any and every right triangle, the sum of the squares of the two legs equals the square of the hypotenuse, also known as A squared plus B squared equals C squared. So we want to prove this. Here's how I'm going to go about doing that. First, I'm going to draw a big square, or something that mostly resembles a square. You'll have to forgive my lack of artistic ability. And now I'm going to draw another square on the inside of this one, kind of as like at a tilt, at a diamond shape. Now it doesn't need to be exactly in the center of these two sides. In fact, I'm going to intentionally put it a little off to the side. But as long as I'm the same a little off to the side on every side, it'll still make a square. Yeah, that looks pretty good. So now we got to start labeling these sides. All these inside sides are all the same, so we can just call them C. And on this outside, I have a short part of this triangle and a long part of these little triangles. So we'll call the short part A and the long part B. And because I made this inside thing a square, all equal lengths, I went the same length over on every side from the center. That means all of these lengths are A and B and A and B and A and B. Take a moment to convince yourself that that's true, that all four of these triangles are the same. It's not exactly obvious, but it should become pretty clear once you give it a moment. So what do we need for this proof from here? We only need a few things. Two facts from geometry, that is the area of a square. And you'll remember that's just its side length squared. We'll call it side length x. We need the area of a triangle, which is 1/2 base times height. And then we'll need to use a little bit of algebra as we go through this. So how do we set this up? First, I just want to express the area of this big square as simply as I can. What's the area of a square? Oh, it's a side length squared. What's a side length? Well, in this case, a side length is A plus B. So we'll write that, A plus B squared. So that's the area of the whole big thing. So what's another way we could write that area? We could write it as the sum of all these areas of these five little shapes and added together. So let's do that. So area of one of these little triangles, go back to our formula. That's going to be 1/2. Base times height. In this case, our base and our height are A and B. Doesn't matter which one we consider which. So area of a triangle, 1/2 AB, but we have 1, 2, 3, 4 of them. So I'm going to multiply this by 4. Then we just have to add the area of that square inside, which is just C squared. All right, next step, we're going to multiply out this square. And we do that by foiling, essentially. You'll remember that looks like first terms plus outer terms and inner terms plus last terms. So we have A squared plus 2AB plus B squared. Cleaning up this side, we have 4 times a half. That's 2ab plus c squared. And last step, we just want to combine like terms. So we see we have AB and AB on both sides. That means I can subtract 2AB from both sides. Both those terms just become 0 and cancel out. And what are we left with? A squared plus B squared equals C squared. QED. All right, thanks for joining me on this proof video today. Remember, if you'd like to get tutoring from me, I have links for my Fiverr account down in my description, and we'll see you next time.